This is number 10 on the sample final. Again, it's a Lewis structure. I want you to draw the structure and predict the shape of CS3 2- ion. It gives you a skeleton structure. The first step is to find your valence electrons. We got 1 carbon, which is 4 electrons. We have 3 sulfurs. Each sulfur has 6, so that gives us 18. And 2- will give us 2 extra electrons. So that brings our total to 24 electrons, which is 12 pairs. First step is draw your single bonds to each sulfur. Then let's fill out the octet on the outer atoms and see where we're at as far as total electrons. We need 24. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we have the total number of electrons that we need to have for this structure. The next step is to make sure that every atom has an octet, and you can see that your sulfurs have each got octets. They've each got 8 electrons, or 4 pairs around it, but the carbon in the middle only has 6 electrons, or 3 pairs. So we're going to have to move one of these electron pairs into a double bond, which will give us a slightly different structure. And now the carbon has an octet. The sulfurs still all have octets, and we already checked our total of 24 electrons. Now that double bond could also exist right there, or it could exist right there. As long as you have one double bond in that structure and the other 2 are single bonds, then it's the same structure and it'll work. So now that we have our Lewis structure, we can predict our molecular shape. The formula that we used to do this is our MXE formula. In this case, we have MX3. There's no lone pairs on our central atom, so there's no E. We have 3 bonded groups. In this case, they're sulfurs. So MX3 works out to be trigonal planar. And again, you're going to have to memorize what these shapes are according to your basic structure, your basic formula. So this is number 10 on the sample final.